submit a question if you have any. Thank you, Mr. So at the meantime, if you have any question, remember to submit it through the QR code that is available inside our program. Alright, as mentioned earlier this morning, and we can have it during the last session, during the Q&A. So for the next session, we will be inviting Engineer Tan Chin Su to speak to us on the common challenges in design and construction of micropiles and other foundations on limestones. And just a little background about Engineer Tan. Engineer Tan is a geotechnical engineer with 45 years of experience in foundations and geotechnical engineering works, and he is also the founding director of Shinei Geotechnique Sdn Bhd. That's it. This is better. Shinei Geotechnique, the company he currently leads. Armada is a registered with the Board of Engineers Malaysia. He obtained his Bachelor of Civil Engineering at the University of Manchester and Master in Foundation Engineering at University of Birmingham. So Armada has in 1989 became an engineer at Geotechnical Consult Sdn Bhd, where he was mentored by the late very famous Professor Chi. He later joined Thomas Consult and hit their geotechnical department, and he was involved in the largest diaphragm wall work for UDA Bukit Nangas project and Chong Tiao Bank headquarters, now which is referred as the UOB Bank at Jalan Raja Laut. So Engineer Tan has a very wide experience of geotechnical works, and he was involved in a lot of these piling works in Malaysia, which includes wall piling and second piling works. And Armada has also joined power, in which he became a leading piling contractor in town. He was much involved in the repair of the highway, East-West Highway, and etc. projects. I think with that, it's a good introduction to Engineer Tan. Let me take over for his topics on the challenges with micropiles in limestones. Thank you.
Very good afternoon to all of you. I notice the crowd is very large, which really shows the interest of all of you in limestone. I'd like to thank the end for hosting the event. I always remember our late team when I was a national engineer. We were we always come and say, look, you all must continue to pass our experience to the younger engineers when we continue to grow in life. Well, this is something which I always remember, and I enjoy doing these experiences to new engineers. We do take in some trainings, I do enjoy teaching them. I think it's just a passion that we want the school engineers to give the juniors. So that whatever we learn, at least we transfer to them. Because still see my voice and music. The last few days was up doing well. Short degree subject, and I noticed actually the previous speakers, they have gone through limestone formation, some investigations substantially. So I'm very quickly brief a little bit on what I feel regarding the physical technique, and I go into the limestone, the micropile, and the limestone. Limestone has always been the biggest headache for developers. Because we don't know how much we're going to dig into socket. And for the consultant and engineers, I think the biggest challenge for them is always trying to get a good solution in an area so difficult to determine. And at the same time, under the pressure of the client, we don't really budget. And for us contractors, it's slightly different. It can be a gold mine, and it can also be a land mine. It all depends on how we contractors and the client negotiate the contract. And the later part of the talk, I will be touching on the little bit of contractual matter. And this is where to avoid much dispute and difficulties with regard to foundation concept. As I said, it can be for contractors, it can be over. If the client engineers do not do it right, we have been to that situation, but we have also gone to the next one when we do so long. Besides challenges, the operation of the drilling machines, the techniques of drilling, we are going to installation challenges. That's where we, micropiles contractors, do find a lot of problems as well. The last week I should go into the contractual challenges. And finally, some case studies. You will notice the next few slides are the repeat of the crew of three speakers. I guess every one of us might have just tried searching in the net. And we all end up having the same information the third time, I think. I'm not sure, but I think it's the third time. But this is a very good presentation. In fact, I like this very much. And of course, we are at the last one, extreme casting formation, where bucket caves and all that are shown in this. I think it's done by the American Walton and Fuchs. The next slide, I believe, is John and Khan. That was also repeated. Yeah. The next one, Mr. Neo again repeated. So I'm not going to that. But this next slide is slightly different. This was not published. This was done by me about 40 years ago. Can you imagine? 40 years ago, that's in the early 80s. Of course, there were a lot of building in KL, more power, driven power. But at that point in time, I was still a young engineer then. I was young then. And we were promoting micropiles at that time. And I believe LNM is the pioneer in promoting micropiles. And of course, we were using DVD bars. We were using ODEX system at that time because we faced some project where we required our system, the ODEX system. I shall be using this sketch for the rest of my talk regarding the various problems associated with limestone. You will see that on the left-hand side, I'm talking about the ballpark problem. On the right-hand side, I was talking about the driven power problem. But actually, today, after 40 years of major development in KL, both ballpark, driven power have come to a stage, I believe, the experience are very wide, and they are all capable of doing the formation, whether they are ballpark or they are driven power. I think they are already enough experience that this can be done. As one of the child was talking about jetting power. The third was talking about power. I think certainly for today, where our building are going up 50, 60 story, that is the solution. Why? Generally, they will be cheaper. More power, jack-in power or driven power, high capacity, is likely to be cheaper than micropile. The micropile cost is only generally for the lower end buildings. But at the lower end building, yes, we may be able to compete. But very often, I watch them on time. If you have a solution, don't use micropile. Because we are almost like the Rolls-Royce of the power industry. It's one of the most expensive. And many of my colleagues were very upset when I go marketing. I go there, I will lose my job. But we just want to tell the truth. Okay, this is the same problems that have been repeated. I just underline them. The steep incline, the overhang. I just heard that someone just said, don't talk about floaters. But floaters still stay here. I think one of the big problems I will talk about is on the left-hand side. That is long and short power. So when it comes to the caustic foundation, the micropile, yes, it's a good solution. And the other advantages, of course, is lesser in noise compared to bore power. Compared to driven power, we are much lesser because we're always using a compressor and the engine of the rig is not very loud. Of course, environmentally, it's a little bit more friendly compared to the big pump system. There's a bit of vibration, a bit of noise. Sensitive buildings, yes, yeah, sometimes next to big sensitive building, your other system might be a little bit of nuisance. And of course, in some area where very tight space, the big machines cannot go in. The micropile machine, smaller in size, we are able to handle it. A lot has been talked about Mark regarding the soil investigations. I still like to reach a little bit on the soil investigations from the point of the soil contractor. Yeah. So I'll just go through very quickly this part. I think when we contracted the soil report, our first instinct is to look at where is the dock, and where is the SPT. That is always the first instinct when we tender for a project. But of course, there are more things we do. Sometimes the SI report that we receive, they just give you some boundary and nothing much. Not even road names. Contractors like this, you want to comment where is the sign or you give the location. So I think it's important to give as much information in the source report. Levels, for example, I've come across where the levels change. The SI guy took some levels at the time when we see the tender drawing and construction drawing, they use another set of levels. So it's very important that, and I believe most of you consultants, when you started the job, you would have your land surveyor to take out the topography. At that point in time, pick up all the relevant information and if possible, put it in the soil report as much. Then we have the tenderer to have more information. And of course, in the soil report, we also look at the detail of what is described there. As one has been explained, the loss of water, all these are important for us, especially in Limestone. But the most important part is this part of all the rock. The rock centers. As a contractor, we look at rock centers. If you see that the rock centers is full of cracks and all pieces, we know that it's easy to go through. But once you see a solid core, that's different. Right? So it's always good, in my opinion, that the rock centers, I would encourage that the consultant explain to your client, keep the rock centers. if possible, keep until the end of the construction period. This is the average scopes. Very often, big volumes of this rock sample will be discarded. And of course, we still look at the soil report. Nowadays, all soil report are being covered for the ground. That's very useful. Because from the rock samples, it gives a good indication of the type of tools, type of the method, and all this, and that affects the costing. So that's what I expect. Hopefully, that more information and relevant information is put into the soil report to assist the of course, most important about sufficiency of soil investigation. I think this is the most important part. How to make sure that as I give you a reasonable representation of the profile that we are working on. And this is just an example. If you keep all the top part of the rock, what will you do? You tell your client is only X dollars to budget. But in actual fact, at the end of the day, the past go around there. Then you have a problem. And the reverse may happen. If you did go into deep paths, you give a bigger budget, the client will just think of you why so deep, why so much. So it's very important that we have enough soil investigation in order to give a good result. This is another chart we can show. Ball 2 and 5 looks still there. So the micropile contractor, we just socket as what we were told, put 2 or 3 or 4 meters. But in actual fact, we may have a situation like this. A very sharp through here, we do not know. Because in between, there is no information at all. Is this risky? Well, we need to discuss this maybe together later. But this is just a simple illustration about what has also been briefed by previous speakers to phase out the investigation. One thing, I always think this way, it is to convince your client to have sufficient budget. Of course, then you phase it out so that the money spent is progressively, but there must be sufficient. And also to allow it during when the foundation contract is awarded, there must also allow some provision for further investigation. When you are in the Limestone area, I would advise that this should be explained to make sure that the client has sufficient budget. And give you an example. I mean, we bought a unit, invested in a company. The day I collected my key, they gave me a check 50,000. Why? The whole project was delayed. Delayed a few months, and all the purchasers were all very happy because the renter is so poor, the liquidated damages were so good, but only one purchaser I got 30,000-40,000. So what is there to put a little bit more money in the S9? So you have to convince the client. How to convince the client? I think the best way to convince the client is pick up all these years, all the project that has suffered substantially. Show them how the developer has suffered, how much they have paid. In some cases, they have millions to pay to the purchasers for the R&D. So pick up all these real cases, show it to a client. I'm just doing just illustratively for this one. And this is what I say. When we get this to top part, we look at it, it's very easy to do. But when we come to more solid rock, then we have to be more careful in our pricing. Our design calculation, and these are quite straightforward. In the micropile, the two main elements are the scale and the concrete or grout. At the moment, of course, we are using steel bar, APA pipe, sometimes pitch sections or perhaps even rail paths. And the ground strength we are looking at is in the range of we started usually at the low end, but nowadays some consultant has come out as high as grade 35, which is a bit difficult to obtain, but generally grade 30 is the accepted range. And the diameter of our is often quoted as 6 inch of 150, 200, 250, 300. Just be careful of this now. This is a very typical size that we put in the design. But when you come to Audex, which I will explain a bit later, Audex has a limited type of dimensions. And this is got to do with the way the Audex system was manufactured and how the tolerance provided in order to be able to suit the Audex system. So it's not exactly that type of diameter if you have to use the Audex system. Oh, sorry. So this is normally the calculation I see many of the designers are using for the capacity, the actual capacity of the micropile. I'd like to explain a bit regarding the material. I would prefer to use the API pipe. For the various reasons I've stated here. Number one, as compared to the bars, most of the, I won't say most, very often the tender joint ratio steel bar. I always try to convert the steel bar and use API pipe. This is the reason why I prefer the API pipe. First, the joints. The joints of the API pipe, are big. Meant for the oil industry, so they are going thousands of meters into the ground. So they are a lot stronger joints, in my opinion. Then we use threaded couplers in the bar system. And of course, the joint is very fast for us, for the workers to join them. With 2 branches, they can join up 2 bars. Whereas in the case of the bar system, many couplers, there are 4 or 5 couplers, so it took a long time. Because technically the EI generate of the same capacity, the API pipe is much stronger. Installation is faster. The links are not required in the case when I use the API pipe. And I meant, in my opinion, it will be a little bit straighter when you use the API pipe. Now, the labor cost incurred during the bar system is quite a fair bit. Because you have to send the bar to the trading company, send it back to the yard. So actually the cost is minimal difference when you use API pipe. The job chemical capacity, basically we don't use much friction in the overburden. So we end up only in the rock socket part. In the rock socket capacity has been tested many times. So there's a range of capacity depending on the quality and the weathering of the rock. Buckling, from my experience all these years, buckling has never been a problem. However, some long paths, when we tested it, the road test may show that the arm is filled. But eventually, when you unload it, it gets back to almost to its original position. That's mainly because the car actually goes banana, but it is not fair. Right? So there is some cases when you look at the result, you may get worried. But when you unload it, it's still okay. So buckling has always never been a serious problem. And that's when company design that are usually adopted. Now, we can't do actually now designing the house. Yeah? So we look into areas where there are floaters, there are overhang, there are pinnacles, the differential settlement, and most in the steep surface. So this case where you have a floater. If the floater is big enough, contractors will just install according to the design, 3-4 meter socket. If all the piles go in 3-4 meter socket, nobody bothers after that. From my experience, first, the presence of floater is never known to us. In the sense that consultant don't specify, contractors will do according to the design socket. Will there be enough S actually to tell me the size of this building generator? So when we come to a situation which we think there's a problem, and in most cases, there was never a problem. I have not heard of any problem of a situation where the building moved. The same as the next slide, the incline. The overhang. When there's not enough information, you see, we always think that it will be in this shape, but unless we know that the thickness of this, we just drill, put 3-4 meters as required. The problem will arise if really there is a necking here. If there is a necking here, the problem will arise. What do we know? That's a question I would like to discuss further and with all of you with regard to this sort of problems. Again, we always worry next this. Are we able to detect them? If we are able to detect them, yes, then you are worried. But in all my years of working, I don't think I've ever come one, and neither am I in question whether I'm in a border, whether I'm in a city or not. That's the situation we are in. Sorry. This is another case. I've done a design where it is my own design, it is the contractor's design. This is a very worry. When I hit a short bar here, in the same column, I hit a long bar. Because they were at the edge of a cliff. That can be a problem. I will know it, I'm doing it, I will take a concern. What do I do? In this case, there will be a need to relook at the whole design. The same thing happened here. One column, short bar, one column, very long bar. Again, the same situation. Once you did this, are we worried? Will there be that excessive settlement, differential settlement? So far, I think none of the consultants that I work with has ever monitored asking me and stop me. They have to check each of these one length in each column or between two columns. I'm not sure. Maybe later on, as I say, I like the view of the consultant. I'm talking with the point of the contractor. When I drill, if it is not my design, I go according to this. If it is my design, I make up a little bit hard because I don't want my building to crack. Then I will have to do something. What do I do? What do I do? Basically, I go back. Sorry. So in the case like that, when we are providing our alternative, certainly I will do something here. I will increase the number of piles or increase the capacity of the pile, that is using a larger API pipe or insert some steel bar into the API pipe just to control the elastic shortening. But I think there is a real concern if you do face such a situation. Yeah, sorry. Yeah, this is another one which I spoke about just now. When we hit this situation, we do not know whether we are at the edge of the cliff or not. If there's not enough SI. Yeah. Or the speed of the people and the understanding of the drilling operations. The drilling methods, the micropile equipment, drilling in limestone, different ways of doing it, the bits, or expect a little bit more convex, and sometimes we use a hydro hammer. And last but not least, the quality control. Basically, for the micropile, it's the rig itself with the boom, and the key part is this rotator that will give you the rotate action, that will rotate the gates. And if you put a downhole hammer here, it will give you the percussion hammer for the downhole. And in some cases where we use vibro hammer in solid casing. So this is basically the equipment that are used for the micropile rig. The medium of the flushing, most of us will use water. That's not the cheapest, right? If you are in a dry area up in the hill, for example, then you can just use compressed air. We seldom use polymer forms of electrolyte. We do it in the known that this can be used. Usually in very collapsible area, we just continue to case like hole. So in the use of electrolyte, polymers are more often used in micropile. That is costly and also difficult to dispose of. And of course, and now I want to, you make equipment, of course, first you have a base crane that hold all your working weight. Yeah. And then you have if it's a large project, you need a crawler crane. That's to expedite the work. And back to that rotator, the range of torque, the turning capacity is the range of about half to 2 or 2.5 ton meter torque. This is the turning capacity of the rotator. And it can be operated hydraulically or electrically. And you need a compressor, water pumps, grout pumps, and all the accessories. Yeah. These are the list of equipment we use at the site. You will notice that it's quite a lot of equipment from micropile, which this is typically rigged on the track. This usually are for larger project, bigger diameter, deeper holes. Then we have this smaller rigs, which is on steel, which can be supported by some scaffolding. These are the lighter machines. Of course, some of them use for underpinning. You have to shorten the boom for the underpinning works. Now, come to the drilling operations. Basically, in limestone area, your alluvium overburden is extremely loose, water, and very difficult to maintain a hole. So it's always a case during. So the casing is always required in the micropile drilling. Yeah. In a situation where if the edgeline are shown reasonably flat now, like we do not need to use the ODEX system. What we do is we install the casing now, and then with a solid beam, we start drilling into the limestone. If you are slightly on the incline, you do it slowly, and you key the beam into the limestone. And basically, you use some cutting sheet here. That will be the cheapest and fastest. However, when you come to plastic formation with all the inclines and cavities and floaters, then you need your casing to go all the way down until you find the solid bedrock. This is where the ODEX casing will come into use. Actually, ODEX, if the meaning of ODEX is basically meant overhead during eccentric beat. It's a short form for overburden during. The EX means for eccentric. I'm going to show you what this eccentric beat means. Okay. This is just not the solid beat I'm talking about. Yeah. That's the hammer. And of course, the beats are all fitted below here. The percussion action, rotary action, will act onto the beats. Now, we look at this connection. Basically, this is the eccentric part. Right. During the insertion, this is all within the same diameter. Sorry. This is the next step. Okay, I use this one to easily describe you. This one is the hammer. This is the ODEX system. Right? The yellow part. This is the casing. The temporary casing. Welded to the temporary casing is the casing shoe. Alright, now we look at the next part. The casing shoe here is welded. We are casing. On that casing shoe, which is this one, you see that there is a little nick here. Right? This is where when the ODEX hammer moves up and down, it's going to hit that casing shoe. Right? You hit that casing shoe, and it will drag simultaneously that casing tower. That is the advantage of this ODEX, that you can take the casing down all the way through your rock, through your cavities. Of course, the horse spin of the system is a lot more. When we hit the rock, we just have to make a turn, and the eccentric beat will move outward. You will see that it will hit. It will drill a bigger hole because of the eccentric position. As I said, in larger jobs, sometimes we expedite the installation of casing with a vibro hammer. Especially when we have bigger jobs that allow the cost of crane and vibro hammer. Basically, it's just the installation process only. And at the tip of it, you can either fix your casing shoe or you have a direct beat, as a solid beat. This last one is important. Basically, you want to control verticality, you want to check that your precision is correct, you don't have ECC problem. And of course, finally, when you get your net right, you do your grouting, and you make sure that there is sufficient grout, good quality grout that comes out. You always want to observe that It is not the initial water, the root water in the ground. Now I'm going to talk about the difficulties we face in the limestone area. We go through all these different problems that we face. But all of this, and we see that over the years, there is already enough experience to overcome all this problem. Yeah. So that's why when I was asked to talk about problem, I was telling myself, actually I do this problem. All these years we have already, in a way, gone through the learning process. Yeah. In fact, I had a hard time thinking where the problems are. Okay, let's go through. Again, back to my first slide. Right? If we know, as I said, if we know that there is a floater, it's very simple. Right? We just go through the floater, bring our casing down, that's it. And we, of course, we will have to use the ODEX system. Next. There is a small problem we will face. If the border is small, you will know. Only the operator will know. When the border is small, we will face problem. Why? Because they move. When they move, right, it will jam up. When the border is a bit small, this will jam up a bit. We will have some problem in this case. Yes? What normally we do, if we face this problem, we can do some grouting work just to sort of solidify the region here. So that the small boulder will be locked in. Yeah. Okay. Very often, just around the top of the limestone, you always get this gravel. Now, gravel, if you think about gravel, you don't think it's a problem. Actually, they do give you some problem. The gravel, during the time when you was flushing your material out, right? What happened is, this gravel finds its way up, but it's too heavy, it floats down again. I mean, sink down again. So we have a collection of gravel. This makes the drilling process sometimes not possible at all. So the only way what we do is we pull out everything, casing, all the tools that we install, we pull them out and start pressure drop. The pressure drop to solidify this area. So that the gravel are all cemented. So this is an operation that we do for some time with very gravelly ground. The same thing overhang. If we know this overhang, if we do not know, 3-4 meters we just suffer it. But if we know it, we are worrying about it, only way again, we just go down, into the next level. And then it means you need to go and use the ODEX system. Again, the same thing. When you have a cavity, the operator will know, because there will be easy drilling, there will be potentially loss of water. So again, the same situation. Once we face this in the cavity area, we just want to tell the consultant that I'm sorry, there's no way we're going to release the casing and we go down until the front ground. Go to a cavity and sort it out. You can't handle this. You can't grab all this area. So we put down the casing. But of course, in some of the tender, the consultant might say, okay, how about grouting it up to fill the void? And this is a question sometimes pose a very difficult situation, because is the permanent casing cheaper than coming robbing? We never know. And as I said, if I paid for the cement bag that goes in, I may opt for just something more. The more I opt, the more I get. There are many ways of situation I say we all face difficulties like this to decide whether it's permanent casing or pressure dropping. Again, once you have this zones and qualities, you just do no choice. You will just go to install a permanent casing. So whenever a permanent casing installed, there's no other way. You still got to use a conveyor system. Excessive ground loss. You are drilling through an area where you did not face any problem. Until you start to do no problem. But when you ground it, then suddenly you realize your ground is looking out tremendously. You can't feel at home. Just complete loss of the ground. Then you know that we got a problem here. There will be interconnected cavities, a very porous zone here. The only way out of this is we actually have to pull everything out. Pull everything out. And pressure down again. Hopefully that the pressure ground will seal up the hole. Now, the question again arises, how many bags will you put it in? Because the intake will be a lot. So this is again a question about writing a reasonably fair contract when you have a problem like that. Both the consultant, the client, have to understand the situation like that. This sort of risk, how to mitigate it. You have to talk about it before you sign the contract. Both parties come to a compromise position to handle this excessive loss. There will be another case where when we were grouting, everything was good, and suddenly halfway through, the ground was. It's not at the beginning. Somewhere we pull out the casing, the ground was. Same problem that we have found. Yeah. So we will stop the extraction of the casing. Yeah, we go back, we try. Go down again. Right? Lower down again to a time zone. And then we leave that casing as permanent. Because we are uncertain about how much to drop here. So all these situations are the difficulties we face during the installation. And of course, all this is time-consuming and it costs money. So all these are the type of positions that got to be settled at the early stage. When we come to inclined foots, the experienced operator will be able to tell you, the moment you hit an incline, your rear rod will certainly tilt, and then the resistance is different. During the rotation, you can feel it. So, once you get into this, the first thing the operator will do is slow down the process. Very slowly, you try to go in at a very slow rate, try to get into it. Yeah. Of course, you may not be able to do it. At times, you may not be able to catch it. So there will be a relook at the whole thing. If you get a chance to key in the return, right, then of course you continue to get into the software. So in a situation like that, again, needs a lot of experienced operator to handle this. This is some situation that we encountered. What we did, very often we drill a few holes and we do the grouting in one go, right? So when we start grouting in one of the holes, then suddenly grout actually do connected to another hole, then we see ground coming up. But in a situation like that, what normally we do is we try to ground them simultaneously. You don't want to have while you're grounding this and the ground comes in. What's going to happen is this casing may not be able to retrieve, and you may not be paid for the permanent casing. So normally, what we do is we stop the grouting here. We will grout 2 or 3 piles around the same area simultaneously, so that we can pull all the casing out at the same time at the end of the grouting to prevent the early set of the grout against our casing. Of course, then, occasionally we got timber. But once you get timber, it's almost very difficult. We can the hammer and the disc can make the hundreds drop, but when you come to timber, it's a disaster for us because we typically hammer, we can't break it. So in that case, very often we have to redesign or to shift about, redesign the configuration. And once in a while, you will get another tile. Once in a while. There is, I'm talking so much about the organics that are able to help us, but there is also a setback here. Yeah? On the side of the expensive, more expensive than the other system. The setback is this. As I explained, the eccentric drilling enlarged the hole bigger than the casing. Yeah? So when it's bigger than casing, sometimes you may overflush, and the material actually flow out from this gap. Then you have lots of material here, right? Then you may get some sediment at the surface. If you are near some building, you got to watch out. So when you are building the other system, very near at the boundary where they are all buildings, sensitive building, then there's a need that your operator got to be extremely careful, right? To avoid a situation like this. And this may happen. In fact, we had 1 or 2 problems like this before. Okay, now I go to the next part. The contractual challenges. This was not given to me as part of the work, as just to talk about design and installation. But I'd like to go into this area because as a contractor, we are there not just to finish the job, we are there also to make money. So of course, the contractual aspect are important to the contractors and of course to the clients. Yeah? So the answer from the contractors challenges come through all these difficulties. Right? The geological uncertainty, drought, losses, material losses, delay in the work, the design responsibility, variations and disputes. There will be a lot of equipment damages if they are not careful, and of course the quality of the work and testing. All these are issues that will give rise to a lot of dispute and long delay. I'm not going to read all these. Basically, it says here, the site investigation responsibility. This is a subject of interest in maybe we can continue after that about this responsibility with the other consultant contractors. Who is responsible for the site investigation and its accuracy? This contractual problem will give rise to a lot of delay, and the contractor will need extension of time. So there will be this mitigation that the contractor need to do into the conditions that are unexpected, and how to manage all this through the various investigations, whether contractors can ask request for the clause of unforeseen situation, of course, contingency in the document. So all these are the factors that are going to give rise to contraction problem. You see, you have this classic situation, then you have a fixed price contract. It is non-sum. Right? And the contractor that absorbs the cost of completion material. But this is a challenge again for the contractor. There will be disputes, and the client and consultant may argue that all the losses of this material is due to our program, due to our fault. So where are we going to, how are we going to manage that? Can we specify on the tender document the cost for all this? And this is a question that needs to be discussed during the tender stage. Of course, during the tender stage, there could be a lot of very strict requirement. But it is up to the contractor and the consultant to negotiate a reasonably fair arrangement. Detail part of it. You may go into detail in each of the items that you are having problem. And you record it, make sure that all these are properly recorded to avoid long litigations. There will be situation of hard rock activities. I'm not going through all this, but basically, I've already mentioned these are the kind of problems that we are facing. That this design problem. The challenge is in design a great contract. The contractor is responsible in the design, right? The contractor must ensure that the parts are contractors like this design and they are adequate design, right? To bridge over all the problems. So the contraction risks are the design risks, inadequate, enough or not enough space time, and of course meeting up test compliance. So in order to mitigate this, during the discussion stage, all these issues ought to be discussed clearly and the negotiation stage. So we have variation and disputes. And both sides have to look into all this in detail. Equipment damages is another problem, and the contractor will be first. For the contractor, for us, is to ensure that we have good equipment, enough stocks, space, and experienced mechanics in order to avoid these disputes. And of course, sometimes we take a proper insurance to cover the risk. In terms of quality, in terms of quality, the Limestone is giving a lot of different conditions. So there will be again disputes when the different conditions arise. There must be a way to thresh out all these disputes during the negotiation stage. Important to have the contractual risk management. What are the risks that the contractor working limestone, right? Will mitigate their risks. I think very important, already it is taught by previous speakers, compress is site investigation. That is the key thing. And make sure there is sufficient budget for your SI. And you must have very clear contractual process to avoid these disputes. And of course, there will be a need for proactive management in this management of the contingency during the work. Maintain a good communications among the engineers and clients and project managers. These are essential because of the amount of risk that we often face in limestone. Okay, now I come to, I don't know what's the timeline. Okay. Yeah. I would like to go to a few of the projects that we did. It will not necessarily be micropile, because many of the projects require various foundation systems. This is storage treatment plant that we did in Batam. This is perhaps the biggest and the largest circular coffer dam ever done in Malaysia. This is in Ipoh. The diameter of the caissons was 56 meters. The depth from the ground to the final excavation, the deepest is 25 meters. What we did was, okay, these are all the work that was done on this project. Continuous CDP, 1 meter diameter, rock shocketer. Every of the mobile we check for cavity. Every one of them. There needs to be 3 more using a micropile to go through. Not everyone, sorry. They actually do every 3 CDP you go through in the micropile to check. We do check routing, base routing, monitoring. The restraining system is basically the capping, the ring beam, the capping beam, and the ground anchors. There was no stopping, of course. And of course, the excavation, the hydraulic, we got a hydraulic breaker. Well, I was already involved. Shinei was already involved in geotechnical work. The main excavation is done by another contractor. There was some rock slope stabilization. Sorry, I keep doing the one. And then at the base of this, some tension piles. And of course, filling up of the gaps of the CDP wall. This is the ground level. And this blue color here is a rock profile. Right? And we are to excavate, to construct the permanent wood inside. Here. That means there is about maybe 10 meters of limestone. Right? The unfortunate thing is, CDP is short here, the CDP is longer here because the rock profile went down. And we are able to do the capping beam, the ring beam, first level, second level, third level, continuous ring beam. Then when you come to the fourth level, I can have a circular beam any longer because I'm encountering limestone. So in the area where I can't reach, I can't get the ring beam together, we were using ground anchors. So in the short CDP area, we were using ground anchors. It's a pretty hard material. Initially, the contractor tried to do blasting, but no permission after the effect was stopped by the authority. But there were some neighbors. The engineers also require us to do the tension parcel to hold down this basement. This tension pass. And there is also a requirement to do a lot of what they call pressure logging at the base. These are the pressure logging house. So they're not pressure logging. What he called it as a sealing of the gaps. So what we need to do was just to drill. I got a bit mixed up. So these are the tension paths. These are the tension paths to hold down the base. Now, in order to cut down the cost, the consultant design was every hole we put one Y32. But we managed to redesign to put 3 bars in one hole. In short, we are able to cut down the number of tension bars substantially. Basically, the thickness of the step allows us to space the tension bars apart. That's the plot of the CDP. You can see the various layers of cavities of limestone rock. This is typical soil report where you will get the multi-layer cavities. These are the ground sealing of the gaps. This basically is pressure drop. It's an arbitrary spacing that the consultant put in, and we just drill at the base and pressure drop. This is a document for the cavity proving at the beginning of the job. At every 3 CDP, we use the micropiles because they can do it fast. Of course, they're a bit costly compared to use the SID to check the cavity. And we are constructing the CDP here. And these are the rock centers they are called out. We do have, unfortunately, sinkhole as well. During one of the operations, the sinkhole appeared at the site. Quite a deep one. It's not big like it, but it's relatively deep. Installation of infilling. The CDP was actually steel outside the ground column. So every gap of the CDP is sealed with a ground column. This is the construction of the ground. Excavation stage. Once you reach the water, where my ringing cannot be fully circular, then we have no choice. Then we will have to use power twist. These are the work for sealing all these materials. And this is the raw anchor work. And of course, the final bit on the rock excavation. And the rock excavation, we use the main contractor actually used a breaker. But in order to expedite the work, this is all limestone. We actually assisted by drilling holes. With the micropile of the ground anchor already at the base, we were drilling just empty the limestone, and that helped him to break up the rock faster. ongoing break, rock breaking. This is the motor, I call it motor bridge. This is done by Armada and with the contractors. But this I shall just quickly mention about the use of a rotator. When we entered this job, we were not certain what we could to use. We started with using Micropiles to do and that was the initial design. But later we found out it is too slow and too difficult. We then out for a different system. Actually, we went to propose using the rotator. Basically, the rotator, I think we are the only one with a rotator that has a capacity of 150 ton-meter torque, and another one 200 ton torque. And 200 ton torque, that means it is compared to a BG30, it is 10 times higher in terms of spinning capacity. It is actually a very powerful machine. Because of its high capacity, it can turn to turn the casing. What we need is a double wall casing in order to provide the capacity to restrain the torque. The casing in one of my jobs was done up to 90 over meter. And because the rotator has a very high torque, the rotator has to be restrained. So we have spikes. They are fixed to the base of the rotator. And this is the double wall casing. This double wall casing, you realize that they are joined using screws. They fit into each other, a male and female, and they are all tightened up with screws. They are all almost perfectly in the straight line. So if they are out of alignment, they will give a lot of resistance to it. I mean, you have to turn it down. This is the working stage. Okay, and the last part of the casing, we have a casing sheet, right? And with all the constant to cut into the rock. This is cut into the rock, and later we use a chisel to break the rock and pick up with a camshaft. Of course, this is not like the rock quarrying machine, break it there. We have to use a chisel. This is how the rock pieces came out. Because the rotator is quite high, so you need a high rank to have a ready mix to deliver up to the composition. That's a difficult job. This is a job which I did 20 years ago. Extremely difficult. This project requires all the piling system that I have. And I have also to engage outsiders as well. You can imagine how difficult the job is. Okay, we got heavy probing, and a life more job. The ballpark they went up to 92 meters. And in the life wall, there were some direct parts, there were some columns at the perimeter wall. There were micropiles, there were RC piles. And next to a very old building, we had to use a silent powder for the ship pump. Of course, the excavation starting on 3 meter, and because the depth of the excavation is 16 meter, so there's a substantial distance. To control the settlement deformation of that wall, we preload the internal stopping. There were plenty of jack routing carried out there. And of course, we finish off with the RC work. And of course, some instrumentation.
Engineer time, I still have about 5 minutes.
Okay.
Thank you.
And quickly run through This is the plan of the site. The consultant started with about 20 odd bores. Average depth was about 40, 50 meters. We in out 200 bores. Every part was investigated. Of course, we managed to convince the client for the additional SI before we signed the contract. We knew that there were problems, and the consultant and the client decided to allow us to have the extra ballpark. This one you can't see. Every of the ballpark that we do, we investigated and we proposed what are the systems for each of the ballpark. Some are communicating, some are grouting, pre-grouting. So we had different systems that will overcome the ballpark. I don't even bother at that time don't have a software and actually Dr. Chin, I was my colleague at that time, Dr. Chin. He took a trouble to put all these 200 borders. And he reported on this 3-dimensional border of the limestone. And then he was following the work of Mr. Hong. And Hong started, he also started with this system. I don't know any of the extra outcome ones are here. And these are the work I was doing, the cavity, micropiles, right? You know? Okay, some more work. We were very congested. And we were next to very sensitive building. We had a lot of problems here. The crane fell over and almost killed me. We went to court. It took us only 15 years to settle in court. Never went to court. We had a dispute, settle it, mutually, never went. This is the rotator, right? This is the one, the 200 ton rotator. We started with standing here, but the vibration in the impact is so bad. Eventually, we do a static route. This is a 300 ton route. And this is the one that gave me a lot of trouble. Very often, I look into the deep excavation, concentrate on the deeper excavation. I didn't realize this drain just next to this house. You know, has to drill the drain here. You got to convert this existing drain into the covered box toilet. There's so much vibration affecting the drain. I end up having to look for this silent power. So of course we finished with the silent power. And while I was doing the piling here, a few more piles here, I had an injunction to stop me from continuing. I ended up having to hire a variable frequency library. And there's 9 here. I called out France, they say there are 17 in the world, 2 in Singapore, some charge heavy. I rented that from him, and it's extremely useful. You can stand next to me, very close, you can feel the vibration. I managed to do the 5 hours that had been jumped to complete them with the silent power. That was silent power, the variable frequency. Okay, and these are the stuff. That's a computer job. I'd just like to have the last one of you. This is a 600 ton road test inside a basement of an existing building. The head road is only 2.7 meters. Imagine to be able to bring the cash bins and do those 600 kilometers. There's a problem right in the middle of it. We were lucky. At the corner of the parquet was enough space for me to put 2 jacks. So I have 2 cash bins, one across, and the cash bin I can only do 4 ground anchors. Each anchor is 150 pounds. Working load. Extremely difficult. Why? This is a diagonal 2 basements down, I am about maybe 6 meters below the tank river. When I break through the basement snag, the water was just pushing up. It's not shooting up, flowing up. Due to the altitude, due to the different shear height. I had a big problem. Why? When I was flushing during the operation of flushing the site out, the gravel, which I described earlier, plenty of gravel came up and flowed down, blew up and down. Big collection of gravel that prevented me from going down. I had no choice. Struggle just to do the foreground, and it took me 2 to 3 months to complete this work. What I had to do was a pre-load around each of the anchor and go down with a smaller rig. Then I can go down. Pre-load the entire region to solidify the river. Finally, we got the ground anchor tested to 300 tons in order to give me 150 tons floating load. When I completed the job, I was extremely happy because there were another 30 micropiles to be done on that site. The consultant said, "Thank you, Mr. Tan. The existing part of the micropile is perfect. You don't do the micropile. I run for my life. If I have to do the 30 micropile, probably I would have closed the company." That's the end of the slide. Thank you very much.
This seminar organizing committee, the chairman, Engineer Tan.